Right, guys, let's just have a look at this question. So it says figure 4 shows 4 reactions of cis-butene, and these are the 4 reactions. As you can see, there are 4 different arrows but different reagents. There's one missing there, of course. So if we scroll down, for part A, we need to identify the name of the compound W shown in figure 4. So if we go back up, this is figure 4, W is this. Now what we need to do is look at the longest carbon chain first. So we've got 1, 2, 3, 4, okay? If it's 4, it's butane, okay? I'm going to call it butane because I can't see any double bonds there, okay? But we also do need to look at any functional groups attached to it. So as you can see, there is an alcohol group there. And in your exam, I would suggest numbering your longest carbon chain. So carbon 1, carbon 2, carbon 3, carbon 4, okay? So if you number it, then the alcohol group is on carbon 2. Therefore, the answer is butan-2-ol, okay? So that's how you name a compound, okay? So it's butan-2-ol. Now, the second question, so for this one, we just put a cross on B. So for A part 2, it says draw the structural formula of compound X in the space provided in figure 4. Okay, so if we go back to figure 4, let's have a look at compound X. So this is where we need to draw compound X. Okay, so we've got a bromine molecule there, so we are adding bromine molecules, okay? So if we're adding bromine molecules, this is what it would look like. So what would happen is the double bond breaks, and then we add the bromine molecule. So this is an example of electrophilic addition, okay? So if we have if we're adding a bromine molecule to an alkene chain, it will break the double bond, okay? And the arrow will start from the double bond, it will go to the bromine. One bromine will be electropositive, the other one will be electronegative. So if you see in an example of electrophilic addition, if it is something like Br2 or Cl2 and both of the atoms are the same, then one will be positive and one will be negative. The one that's closer to the alkene bond should be positive, okay? The double bond. That just makes it easier to draw the mechanism, okay? As long as one's positive and one's negative, that's fine. So this is what the overall mechanism would look like. So at the end, we get two of the bromines attached to the carbons. And make sure you remember the bromines are always going to be added onto the carbons which originally had the double bond, okay? So if we just go back to this, now the double bond is in the middle, okay, between carbon 1 and carbon 2, and the bromine is added on to carbon 2 and so the double bond is between carbon 2 and carbon 3, okay, because 1, 2, 3, 4, 2 and 3, okay, and as you can see, the bromine is being added to carbon 2 and carbon 3, okay, not to carbon 1 and carbon 4. So you need to make sure you remember that. Now, for the next question, it says write the formula of reagent Q in the space provided in figure 4. Now, if we look at figure 4, like I mentioned before, reagent Q is missing. So what we need to do is have a look at the product, okay? Again, let me just move this. The double bond is being broken. That's why at the end, we don't have a double bond, okay? So that's showing me that that's an electrophilic addition, possibly, okay? So because a group is being added on, okay? And we also have extra hydrogen. So if we look here, we've got 1, 2, 3, 4, 5, 6, 7, 8. But we've now got 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? So we're adding things here, so it has to be electrophilic addition. Now, as you can see, there's OSO3H. That might look a little bit odd to you, but you only get this product if you add H2SO4, okay? Let me just show you the mechanism for that. That will just make it a little bit easier. So this is the mechanism, okay? So if we're adding reagent Q has to be H2SO4. That's the only way we can get a product like this at the end, okay? Again, it's going to be added on to where there was a double bond, okay? So if you have a look at this, H2SO4, if something has hydrogen in it, the hydrogen will always be electropositive. So it could be HCl, H2SO4, whatever it is, the hydrogen has to be the electropositive one. The only exception is water. That's a little bit different, okay? So when it comes to labeling the dipole, so the charges, the squiggly line with the plus or minus charge, the hydrogen will always be positive. That's because electronegativity increases as you go across the periodic table. And hydrogen is one of the first elements, so that will always be the most electropositive, okay? So the double bond, the arrow is going to always come from an area of electron density, okay? So then that double bond is being broken, and then this bond is also being broken. Again, it's always coming from the area of electron density, okay? So this hydrogen gets added onto this carbon, and then this group that's remaining will be added onto this carbon. So that's how we get this product, okay? So if we just have a look at the mark scheme, yeah, so if you write H2SO4 or HOSO3H, that's fine, okay? And the next question, it says the HBr molecule acts as an electrophile in the addition reaction with cis-butene. Okay, let's just have a look, HBr. So we need to look at this reaction now, okay? So this is an electrophilic addition. Again, if you look here, 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9 hydrogens, and also another bromine there. The reason why it's not 2 bromines is because we're adding HBr, not Br2, okay? Again, that double bond in the middle is being broken. This hydrogen is being added on here, and then this bromine is being added on here, okay? So that's how we get that product. So the question is asking, explain what the word electrophile means. So firstly, if something's phobic, that means a dislike of something, okay? So that's what phobic means. But if something's philic or phile, that means liking, okay? So phobic is dislike, phile is like, okay? So electrophilic means that the species likes electrons, okay? Or the species is attracted to an area of electron density. Or you could say species which is electron deficient, okay? If it's electron deficient, it will be attracted to electrons.